Okay, I'm going to walk through the windmill assignment and highlight some of the things that were wrong on many of the submissions so that you don't have to, I don't have to answer the question 100 times. Okay, so for diagramming the windmill, the first thing I want you to do on every single assignment you get from me or from any other teacher is read the directions. Many of the diagrams were pretty good, but lost points because they didn't read the instructions. Okay? Your diagram should label all the parts and include measurements in centimeters. Okay? That's something that a good chunk of people did not do. And, that's just throwing points away. So do it don't do it on, line here. Do it using some kind of tool or do it with a paper and pencil and take a nice clear picture of it and make sure that you are drawing your windmill. So if I were to do this, I'd say, okay, here's my windmill, my propeller, my axle, my stand, maybe another stand over here. Some people did a lot of different very clever designs. The a straw maybe here for however you ended up making your windmill. And then draw in the dimensions. So this is what, 15 centimeters or whatever it is. Put in the actual dimensions in centimeters. That's a real basic thing. Okay, next slide. So system schemas. A system schema is a way of describing the system you're talking about. So the things that go inside the system or anywhere, they are objects. They are not phenomena. They're not types of interactions. They're not, a dimension or anything like that. It's the earth. Oh, where's my, let me get a nice color for the earth. Love the earth. Okay, earth. We've got the windmill. Okay, we've got windmill. Well, goodness. Anyway, I'm using a little stylus that doesn't work terribly well. But you would just write the word windmill with a circle around it. Earth with a circle around it. Air with a circle around it. The air is in the system because the air is what's pushing the windmill to turn. I would have the pail separate from the rest of the windmill because that's actually changing. That's where the gravitational energy is going to go as it is raised. The table, okay, doesn't have to have that many things in it. Windmill, earth, air. And you don't have to put the fan that's driving the air. You could just say, okay, the air is moving. Doesn't matter if it's started in a storm in the Philippines or if it's coming out of a fan that's right next to you. From the point of view of the system, it doesn't matter why the air, how the air got to be moving. It just is moving. All right? So I hope that's clear. The objects, the things that are included in your system are only objects. Okay? They are objects. So windmill, earth, bucket, air, table, floor. All right? So the other thing that people did wrong on the system schemas is that they did not follow the instructions again on how to draw or follow the rubric, how to draw a system schema. The arrows, the lines, are interaction lines. They are between the different objects that are in the system. So the Earth is attracting the windmill. For goodness sakes. Okay. The Earth is also attracting the pail. And the reason we put double arrows on the ends of these interaction lines is because it's a two-way street. The pail is attracting the Earth as much as the Earth is attracting the pail. The Earth is also attracting the air. And the air is also attracting the Earth. The pail is interacting with the rest of your windmill. Oh, for the love of Pete, come on. There's an arrow. All right. Oh, for crying out loud. Anyway, so these are interactions. They're you don't have to label them at this point. This would be gravitational force. This would be gravitational force. This would be gravitational force. This would be tension between the windmill and the bucket. This would be, if this has legs, this would be, a normal force between the table and the leg of the windmill. But you don't have to put those at this point. You just have to put them in there. All right? Label these babies. I'm not going to do that now because I'm having difficulty with my pen. But follow the instructions and look at the system schemas, or I'm sorry, look at the rubric, and it will tell you what you need to do in each of these parts of this report in order to get the points. All right? So let's go on to the next. Sorry, gotta stop doing that. So we'll skip ahead. All right. Many of the videos were really amazing. They were great, and I really appreciate that. However, some people, again, didn't do the basic stuff. Some people just put the URL for their video here. That's not what it asks you to do, and it's very clear. It's even highlighted. Okay? You must use the link icon in the Classkick toolbar so that I can click on it. If I can't click on it and open it, I'm not going to grade it. Okay? So if you don't know how to do that, let me know, but it should be pretty clear, pretty straightforward. There's a thing that looks like a little chain, a link, up here in the top of the Classkick. You click on that, and it says, what do you want it to be called, and what is the link you want it to go to? That's all you have to do. Then you say, okay, and then you drag that little box over to this place, and then you're done. You should test it, though. You should, once it's already there, click on it and see if it takes you to the right link, right to the right video. That's the primary thing that people did that was not cool with this, and that's a huge number of points to miss. So don't miss those points. All right, windmill pie charts. This is the other thing that was surprising to me. A lot of people basically said, okay, I'm going to use as my first state. There's a windmill here, but there is no air moving. There's the windmill, the air, the bucket, and the bucket is all the way down at the bottom. Sometimes they say it's sitting on the table. Sometimes they say it's down at the bottom of the string and it's taut, but it's not falling any further. And then they say, oh, so the stuff in here, there's nothing moving, so there's no kinetic energy. And the bucket is just hanging above the ground, so the only kind of energy here is gravitational energy, gravitational potential energy. That's not right. Here's how I'd like you to do these types of analyses of energies. First of all, choose a type of energy you're going to think about. So first one would be kinetic energy. Is anything moving? Is the air moving? No. Is the windmill moving? No. Is the bucket moving? No. there is no kinetic energy. Has anything moved in the past? No. Then there can't be any dissipated energy. Can anything fall? Can anything go further down toward the center of the earth without breaking the system? If it's sitting on the table, no. If it is at the end of its rope and hanging there, no. It cannot fall further. Sure, you could cut the rope and then it would fall, but that would be breaking your system. That's not analyzing your system as it stands. Some people said, well, the windmill is on the top of a table, so it's got gravitational potential energy. But you can't realize it without destroying your system. So no, there is no gravitational energy in this system relative to the system as we have defined it. You could always say, well, yeah, I can dig a hole that's 1,000 feet deep right next to it and then drop it in. So yeah, it's got gravitational potential energy, but that's breaking the system. So there is no gravitational potential energy if something can't fall without breaking your system. There's no kinetic energy if nothing's moving. There's no dissipated energy if nothing has moved. All right? Other people said, oh, well, the string is a little bit elastic. Yeah, it's true. Everything stretches just a teeny bit. A steel bar will stretch a teeny bit. But that's also not really in our system. We're not saying, oh, we're going to stretch the string and then let it go and release that energy. It doesn't really play into the system as we have defined it. So I hope that helps with the pie charts. And the last thing is, some of these were extremely thoughtful reflections, and they were really great. And some of them were just, yes, no. Sometimes, well, kind of, sort of, that's not going to get you a lot of points. I hope this is helpful. I will be around today, again, doing grading. So I'm a little cranky. Be nice to me. And work on these because you can get back a lot of the points that you might have missed. Okay.